Question 4 says the quantity P varies inversely as the square of V. Varying inversely, what does inversely mean? So it tells us that the quantity P varies inversely, so it varies inversely as the square of V. So P is proportional to 1 over V squared. This almost sounds like physics where V is pressure and V is volume. And we know that pressure is inversely proportional to volume from physics, but we're not there. And so, using letters of P, V, and K, find an equation relating P, V, and K. So P is equal to some constant times 1 over V squared, or we can say P is equal to K over V squared. It says when V equals 3, given that V equals 3 when P is 4, determine the positive value of V when P is 1. So they tell us when V is 3, P is 4. So they tell us that 4 is equal to K over V squared. Now V squared is 3 squared and 3 squared is 9. So if I cross multiply them, I can clearly see that K is equal to 4 times 9, which is 36. So K is equal to 36. All right, K equal 36. All right, check that again. P is 4, V is 3, 3 squared is 9, K over 9 is 4. We cross multiply to get 36. So K is 36. Now that K is 36, we want the value of V when P is 1. We know that V is going to be bigger than 3 because they're inversely proportional. So as P decreases, V will increase. So let's check it out. Find the value of V. Now P is equal to K, which is 36 over V squared. Over V squared. But P is 1. And so if we switch them around, we're getting that V squared is equal to 36 over P. And what is P? P is 1. So V squared is equal to 36 over 1. And so if V squared is 36 over 1, then V is the square root of 36. V is the square root of 36. And so the volume, if it is volume that is, V is equal to 6. V equals 6. Nice and easy, soft. So V is equal to 6 from this question. So this is a inverse proportion variation question. Very easy, soft. Now let's move on to question 4b. Question 4b is an inequality question. It says, given that x is a real number, solve the inequality. Given that x is a real number, solve this inequality. So it says 3x plus 7 is between -7 and 7. First thing you want to do is get rid of this 5. Just get rid of the 5. Get rid of it. If I get rid of the 5, I can subtract 5 from both sides to get that 3x is going to be less than or equal to 7 minus 5, which is 2, and it is greater than -7 minus 5 is -12. That's -12. Because we subtract 5 from both sides. We subtracted 5 from both sides, all right, to get the 3x. 7 minus 5 is 2. -7 minus 5 is -12. Then we divide through by 3 to get the range for x. So x is greater than or equal to 2 over 3. X is less than or equal to 2 over 3, but strictly greater than -12 over 3, which is -4. -4. And that's the solution. X must be between 2/3 and -4. So represent your answer B on a number line. So I'm just going to put on the number line somewhere -4. All right, and I'm going to put on the number line somewhere 2/3. Maybe 2/3 is right here. I use this fraction for 2/3. All right. Now the solution for x is between -4 and 2/3. So I'm going to put a circle here and put a circle here and connect them. This is the solution. But it says less than or equal to. So I'm going to have to shade this part of the circle here to show that this is also a part of the solution, that x can be 2/3. So x is between -4 and 2/3. And that's how you represent it on a number line. This is so easy, soft, nice, nice and easy. Okay. Now part C. Part C asks us to find the equation of the straight line that is given as x/3 plus 7/y equal 1. And it says determine the coordinates of Q, and it says Q is the point where the line crosses the y-axis. Now, always remember this, what happens on the y-axis? On the y-axis, y is the boss, and so x equals 0. On the y-axis, x equals 0. All right, so hear me out again. On the x-axis, on the y-axis, x equals 0. So to determine the coordinates of Q, we know that x coordinate of Q is 0. So let's plug in 0 here to get 0/3 plus y/7, and that's equal to 1. So 0 plus 7, y/7 equal 1, and so y is equal to 7. Now that we know that y is equal to 7, we have our coordinate Q. Q is the point where x is 0 and y is 7. Q is the point where x is 0 and y is 7. All right, nice and easy. Now, part 2. Part 2 asks us, what is the gradient of this line? So to find the gradient of this line, well, to find the gradient, there are many ways we could do this. We could find another point on the line, and then having 2 points and find the gradient. Or we can just make y the subject. Make y the subject of the formula, and that will give us, it will put it in the form y equal mx plus c. Once you put it in that form, you will clearly see the gradient. So first thing I will do is I'll bring over the x minus 3 to say y/7 is equal to, that looks like minus x/3 minus x/3 plus 1. And then I multiply through by 7 to say that y is equal to, multiplying through by 7, I get -7/3x plus 7, and that is the standard form of the equation. This is in the form y equal mx plus c, where the gradient is m. And so the gradient of this line, I'm going to call the gradient m. The gradient is -7/3. All right, -7/3 is the gradient. This is the gradient of this line, -7/3. That's one method of doing it. Let's say you couldn't bother to do all of that. Now, if you couldn't bother to do all of that, alternate method. It's always good to use other methods. So, or. An alternate method is, you know that there's a point 0.7. Now you can find another point on the line. You can look at, where does this line crosses? Maybe the x-axis. On the x-axis, y is 0. So you could find another point to say when y is 0, you're going to get x over 3 is equal to 1. And if x over 3 equal 1, then x is equal to 3. And so it would cross the x-axis at the point 3, 0. Now, after you have the point 3, 0 and the point 0, 7, you could go ahead and find the gradient. All right, because gradient is then, what is gradient? y2 minus y1 over x2 minus x1. So the OR method would be the gradient is equal to y2, which would be 0, minus y1, which is 7. So you get 0 minus 7 over x2. x2 is 3 minus x1, which is 0. And so when you do that, you see that the gradient is negative 7 over 3. So this is just another way you could do it if you didn't want to write it in its standard form. All right, depends on what you feel like you want to do. It's always up to you.